I have the voltage regulator pulled out and I've got it on the breadboard for testing purposes. And I got to tell you, really no issues. This voltage regulator is a L7805C as in Charlie. And it has a maximum input of 18 volts DC with a maximum output of 5.2 volts DC with a minimum of 4.8 out. Pulled it out to test it, and like I said, it's working just fine. Let me show you what I've done. You're not going to be able to see this in a wide shot. It'd be a little challenging, so we'll just point the camera where we need to look. Right now you can see that we have the bench power supply at 17.5 volts, and you can see that it's drawing unreadable amount of current. And as you remember, when it was in the radio, we had the power supply set to about 16.5 volts, and it was pulling upwards of 1 amp, and it was getting pretty hot. With the device's maximum input voltage of 18 volts DC, we have it at 17.5 volts. Here we have our output voltage of 4.93 volts, and on this meter here, we're looking at the temperature, which is 87 degrees Fahrenheit or 30 degrees Celsius. And here on the DC milliamp meter, we're looking at the top scale, 25 milliamps. You can see that we're only pulling 5 milliamps at 17.5 volts. Again, we've been doing this for about 2 hours. And this device has not gotten hot at all. I can confirm also with this little dude. Take a reading right there off the top. So, not hot at all. So I'm going to say the voltage regulator is not the issue. I will put it back in the radio, and then I will follow its path to see where it's getting pulled down. I may have to pull this transformer out of the way to see what's happening up underneath it. I do have components. I can't really see what all's there. I do have, it looks like maybe a 5-watt wire wound resistor up underneath there and stuff. It looks like we may have either a black diode under there or a black resistor. Yeah, I'll pull this out and test the components. I may pull them out of line to test them, and we'll go from there. Either way, to have this transformer out of the way, it might be a little easier also to access, well, probably not, but capacitor here, and then we got 2 there, 3 there. And speaking of that, I need to clarify, I misspoke when I called this the power supply area. This is not the power supply area. My brain said, hey, the input power's coming in from there, so of course the closest is going to be the power supply area, but it's not. The transformer's over here. The wire for this is running over there. The wire for our AC input goes to the fuse, and the fuse over to the transformer, and then the transformer back out underneath. So we'll check that all out and see what's happening. Anything exciting, anything new, I'll come back. Okay, so I had this really goofy idea. What if I just bypass the transistor altogether and inject my 5 volts directly into the radio and see what happens? So that's what we're going to do. We still have what do we have? Okay, we have the voltmeter bypassed, temperature meter bypassed. We are still connected to the current meter though. Radio is turned on, and we are all jumbled up. Okay, so we got chassis to power supply going in there, and then coming out here. So let's go ahead and put this on the output side of the transistor. I know you can't see, do apologize, but we could see this. That's all that's important, right? And I'm going to turn up the power supply. We're at 1.5 volts. Three volts. I'm probably not making a good connection there. Four, 5, and we can see that our current draw is definitely exceeding the 5 milliamps. That's 6 volts. Let me change the meter positioning. We're going to put this all the way up at 500 milliamps. So now we're going to be reading the bottom. You know, the bottom that you can't see. Alright, so let's go ahead and drop that down to the 100. So it looks like we're pulling about 30 amps. And let's see if the power supply agrees. Power supply does agree. And we still have no power on the unit. So there we have 8 volts. And yes, we are living dangerously. Okay, so I just pulled out the owner's manual on this device. Let's see if it gives any specs on what it says that it draws for current. And it does not. So we're going to have to do some Ohm's law to figure out what our current draw is. Okay, so if we do Ohm's law on this, and if we take the highest input, which is 15 volts DC, and with the 9 watts, it comes out to 0.6 amps. So with that, what were we getting? You see that big surge too when I hit that. Make contact with that. That slams. So we're around 45. Okay, it just dawned on me I was putting my lead in the wrong spot. So we got about 1.5 volts going into it. There's 3. All right. So at 3.7 volts, we could see that we are pulling more than 0.5 amp, and we have illumination. Okay, I swapped out meters, went digital, a little bit more reading on the output. So let's go ahead and try this again. So we are at 3 volts. And the power supply meter, amp meter, does agree with this. Let's go ahead and turn this up. The radio is working, as you see, but we're pulling almost an amp. Okay, so let me go ahead and troubleshoot this and see what I could find. I'll come back. Followed the trace of the output, and it went immediately into this capacitor right here, and I went ahead and replaced that. That's the new one. I'm not sure what I did with the old one, but the outputted transistor went there, and pulled that out, checked it on my little cheap Chinese meter, this thing, and it did say it had high ohms, but the capacitance wasn't really all that far off from where it should have been. It was a 47 microfarad cap, and I think it was like 56 or something like that. The ESR, according to that thing, was 1.6 ohms or something. Something. So I went ahead and plugged it back into 12 volts and measured the current. It really didn't change. The only thing I saw was 16 volts exactly to fire this up. So I mean, there was slight change. So the plan of attack is to remove that capacitor and that capacitor. Got to tell you, those are kind of a PIA to get to, but we'll get them out and get her done. So I had this goofy idea. Let's just plug it into 120 volts and see what happens. It could only blow up a few times, right? So let's go ahead and do that. I've got it plugged into the isolation variac. Yeah, let's go ahead and bring it up kind of semi-slowly. So we got it powered on. We got this powered on. We're at 0. We're at 50 volts. Not drawing any amps on that meter. Resolution's kind of cheesy. 60, 70, 80. I'm hearing a little crackle out of the speaker. 90, 100. Oh, look at that. It's firing up. 110 and 120. So we apparently still have something that's keeping us down. We need a little bit more voltage into that. Let me crank up the thing and see what happens. Okay, I'm not quite at 100 and whatever we're supposed to be, so okay, I believe here I'm where. Yeah, I'm at line voltage there, mains voltage. So still not enough to excite it. But the good thing is I got it working. Not as designed, but it's working. Alrighty, let's. I'm gonna go ahead and pull out those two capacitors. Got nothing else to lose, right? Couldn't hurt. And then we'll come back and see what happens after that.